In this video, you're going to learn how the Monte Carlo process works. This isn't something that everybody has to know, but it's something that everybody who's going to do risk assessment should be exposed to at least once, because there's a good likelihood that if you move on in this risk analysis stuff, you're going to be doing some risk assessments and using the Monte Carlo process in some of your simulations. So we're going to begin by picking up on the example that I've used in another exercise, which is where we're trying to estimate a gas budget for traveling from one point in the country to another. Except in this, we're just going to focus on the gasoline prices, and we're going to do it a little bit differently. So I'm going to begin by asking you, what is the lowest per gallon price of gasoline that will occur this year? In this calendar year. And I'm going to exaggerate a little bit just to make it a little bit easier for you to see. So I'm going to say, suppose that would be $2.40 as the minimum, and I think it could be as much as $5.10. Okay? So here's the premise. We're basically saying that gasoline is going to cost somewhere between $2.40 and $5.10. For the purpose of this little exercise, I'm going to make the assumption that I don't know anything else. Any number in there is as likely as any other. Now that's not terribly realistic. We know it's not going to be $2.40, and we know it's probably not going to be $5.10. But we're trying to learn the Monte Carlo process, okay? So if you'll go play along with me, we're going to say it's somewhere between those two numbers, and any number in there is as likely as any other. Well, this Monte Carlo process, it has two parts that I'm going to show you here. The first part is the software that's doing this process generates a random number. That random number is usually a number between 0 and 1, and very often our problems involve values that are outside that 0 to 1 range. For example, here I need a number between $2.40 and $5.10. So part 2 of the Monte Carlo process is to transform the random number into something that you can use. So jump down here with me, if you will, to this green cell here, and I'm going to use a random number generator that was used long ago. It's no longer in use. It's too simplistic, and in some instances it doesn't work well. But its value is it's very simple, and we can all understand it. So it begins by choosing any 4-digit number. Anything at all that comes to your mind, you can just type in here, and we begin with a 4-digit number. Notice down here in the yellow cell, I have automatically generated a new number, a second number, simply by squaring your 4-digit number. Okay? So what we do to get a random number is we're going to generate a long list of 4-digit numbers here. So my first number was the seed, 8431. That's not one of our numbers, but we're going to get our number by taking the middle 4 digits out of this particular square. So if I look at the middle 4 digits, they would be 0, 8, 1, 7. Okay? If I divide that number by 10,000, and I use 10,000 because that's 10 to the 4, it takes that 4-digit number and it reduces it to a number between 0 and 1. So I have just generated a random number between 0 and 1. Okay? So, for the moment, let's say the Monte Carlo process has a numerical method or a machine that calculates numbers between 0 and 1, random numbers. Let's look briefly at the transformation. Now I'm using a problem where we want a number between $2.40 and $5.10. And I'm going to use a uniform distribution for this example. I'm doing that not necessarily because it's a realistic way of estimating an uncertain gas price, but because the arithmetic of this particular problem is easy. So I want a number between $2.40 and $5.10. And the number that we have to work with, 0.0817, is not in that interval. So the question is, how do we transform the number that we got, our random number, into a number we can use? And that's going to take a little bit of algebra. And so, as I mentioned, I'm using a uniform distribution. So if you were to take your time and work through the exercise that we're looking at right now, what I'm trying to do is find the number that is 0.0817 of the way between $2.40 and $5.10. The difference between these two numbers is $2.70. So if I take 0.0817 times $2.70, that's 22 cents. I add that 22 cents to the minimum value of $2.40, and now I get the number $2.62. So what we've just done is we've taken the random number 0.0817 and we have converted it into a number that we can use, $2.62. And that's basically how you transform a number. Now let's take a look at how you would transform a bunch of numbers. So we're going to pick another 4-digit number, 7758. Okay, and when I click that in, this random number can come from anywhere. And actually it doesn't have to be 4 digits. I'm using that again for convenience. Notice down here that it's copied the number and we've squared the number. And what we're looking for is the middle 4 digits. So I'm going to put in the middle 4 digits, 1865. And I click on that, and now I have over in cell B72 another number. This time we're looking for the middle 4 digits, and it's not symmetrical. So all I really need is a rule that says I will start with the 3rd digit when it's not symmetrical and use 3, 4, 5, and 6, and as long as I always do it the same way, that'll work out fine. Or, if you preferred, we could start from the 2nd digit. But I'm going to start from the 3rd. So if I start from the 3rd, then the number that I'm looking for is 7822. Now notice there is 1 digit to the right of this, 2 to the left. That's what I mean when I say it's not symmetrical. So just develop a rule and follow it. Now when it squares again, you can see I've got 1836. So 1836 becomes my next mid-square. This is not symmetrical, so it's 7089, and that becomes my next number. Now I'm looking at 2539. And so you see this mid-square method gives me a way to generate a long list of numbers. And I'm going to show you how they're calculating random numbers in just a second. Let's finish this little sequence, 6411 and 1009. And if I've made an error here, forgive me, but I think we'll survive. So the mid-square is what's being calculated from the first random number, 7758. Now notice we take the mid-square and just divide it by 10 to the 4th, since it was a 4-digit number, and I have in column D a sequence of random numbers. So using our same mathematical methodology that we had before, I want a number that is 0.1865 of the way between my minimum and my maximum value. And that number would be $2.90. For those of you who are curious when you get this exercise, feel free to look inside the cells so that you can see the formulas and how these are calculated. But you can notice what we've just done is we have generated a series of random numbers that we can use. Any one of these numbers would be a useful estimate of the gas price, and then we could use this times the number of gallons to estimate a gasoline budget. What you might find is that we don't really have any idea of what random looks like. We think random should be spread out so that we don't see any pattern, but not seeing any pattern at all is its own pattern. So don't worry too much if you look at the numbers and they don't look especially random. So as we scroll down now, I have developed for you a different method here. If you look inside this cell up here, there's another way to get random numbers. What you and I have been doing so far is using a very simple mid-square method. The mid-square method isn't used because it has problems. And to see the problems, just imagine if I'd picked the number 1000 as my first four-digit number, I wouldn't get any random numbers at all. So there are some numbers that won't generate a sequence of numbers. There are other numbers that would generate only a very short sequence before they begin to repeat. And so we found many more sophisticated and much better ways to generate random numbers. Excel has something called its random number generator, and that's what's highlighted up there in the function line. So when we hit enter, you can see the random numbers here change every time we have the random numbers here in this column A, and using the same mathematical formula, I can convert this random number into a number that we can use. Okay, and that's a number between $2.40 and $5.10. It's also possible to do this using at-risk. At-risk is the tool that we use in much of this class, and right now you can see I have in this cell, let me show you when we define distributions. In each of the cells I have written in a formula. Here you see it referring to the value in cell H3, which is $2.40. That's the minimum over here. And the maximum is found in cell H4, which is $5.10. So this is the distribution that we've defined. It's a rectangular distribution called the uniform. It has a minimum and a maximum, and every number between those two is equally likely. So what at-risk does is it has built a number of macros that execute this Monte Carlo process that I'm describing for you right now. Think of it this way. The computer closes its eyes and reaches into this segment of the number line between $2.40 and $5.10. It randomly pulls a value off, and it's going to print it in the cells here that you see in column B. So when I turn on the Monte Carlo process, in each one of these cells, even though they have exactly the same formula, at-risk has generated a different value for us. And the way at-risk did this is exactly as we did earlier. The software has a random number generator. It generates a very long list of random numbers between 0 and 1. And then it grabs the number at the top of that list and it converts it to a number that we can use. The uniform distribution has a relatively easy mathematical formula for doing this conversion. But when we start getting into normal distributions and more complex distributions, then the arithmetic gets a little bit more difficult. And that's why I chose the uniform distribution and the mid-square method. So this gives you an opportunity to kind of poke your nose under the tent, look behind the screen and see how the Monte Carlo process works. So when we build more complex models, what you need to understand is that every cell that has a probability distribution in it, at-risk generates a random number for each cell. Each cell has its own random number. Each cell has its own probability distribution. So at-risk does the arithmetic that's needed to convert the number that's generated randomly in the 0-1 interval into a number that fits the needs of our simulation. So we define a probability distribution like a uniform between $2.40 and $5.10, and the software does both of those tasks for it. Generates random numbers and transforms them into numbers that we can use. If this satisfies your curiosity, there's no need to complete this exercise. But if you'd like to develop a little bit of confidence with it, maybe deeper understanding, please feel free to work this exercise and then ask questions in class if you have any.